to Trig Graphs. Today we're going to do a full teaching on trigonometric graphs. We're going to look at the sine and cosine graph and then transformations of these graphs. Let's get straight into it. What we've got drawn here is the unit circle. Now the unit circle is when you draw a circle of radius 1, and if you do that, then the height, the red line, is the sine, because opposite over hypotenuse, well, the hypotenuse is 1, so opposite over 1 is equal to sine, so the height is sine. So that means that this red line's length is the sine. Now, we're used to looking at the sine between 0 and 90, so if we were to draw it up to 90, it would just go like that. But if we go the other end, it's symmetrical, and you can see now that length is still positive all the way to here, so it draws that graph. But once we get to the third quadrant, we're now going down the y-axis, so the sine is negative. So for the third quadrant, the sine is negative for these values, and it stays negative, but is going back up to be positive. And it would just keep going round and round and round. So that's it up to 360, but you could go round again up to 720. It would just keep going. Similarly, you can do the cosine graph. If we look at the unit circle for the cosine graph, well, now the pink line is basically the value of the cos of theta, the cos of the angle, because if we look at 60 degrees here, remember the black line is the radius, that's unit 1, so cos of 60 is the adjacent side over 1, so the adjacent side is cos of 60, and that pink line is always going to be the cos of the angle. So between 0 and 90, we can see that the cos is the pink line's to the right, so it's positive. But then once we get to the other side, the pink line's to the left, so the cosine's negative, so we dip under the x-axis, and then it stays negative, but it has to get back to positive soon, so it's dipping and it's gone back up. So that's the cosine graph. The tan graph's a bit weirder. The tan graph, well, if we again take the angle on the unit circle, there's no line that the tan represents, but tan is opposite over adjacent, and opposite sine, adjacent is cos, so it's just taking a sine divided by the cos. And when you do that and then plot the values, it's positive in the first quadrant because sine and cos are positive there. It's negative in the second quadrant because sine is positive but cos is negative. And then in the third quadrant it's positive again because sine and cos are negative, and a negative divided by negative is a plus. And on the fourth quadrant, it is negative again because in the fourth quadrant again it's negative again because the sine is negative but the cos is positive again. And then we get back to the start. And you might be wondering, well, what's all these dotted lines? Well, at 90, the sine of 90 is 1, but the cos of 90 is 0, and you can't divide by 0, so you can't draw it, so that becomes an asymptote, and the same thing happens at 270. That's why the tan graph looks a bit weird. This video is sponsored by Lecky, and they are offering viewers of this channel 30% off of any of their books. All you have to do is use the code Claire on Maths, and the link to their books is down below. Now let's look at a couple of their books to highlight. We've got National 5 Maths and Higher Maths, and these are complete revision and practice. 2 books in one. We cover the whole course. Here's a random page, for instance, working simultaneous equations algebraically. You can see how good that book is and how clear it looks. But also at the end, practice exam papers that look exactly like the SQA exam papers that are published. Discount code Claire on Maths. Click the link to order now. Here is the sine graph, which is drawn between 0 and 360. The main points to note on this are this. It starts at 0 and it goes to 1, and the minimum point's -1. So we could say the max is 1 and the minimum is -1. Now, nice and pattern for this, you always go up 90, 180, 270 and 360. 360 is what we call the period, because that's when it starts to repeat itself. So we could say the period of this graph is equal to 360 degrees. And what you need to know how to draw this is you start at 0, it goes up at 1 at 90, then down is 0 at 180, and then -1 at 270, and then back to 360. So there is your sine graph there. Let's do the same for the cosine graph. Well, the cosine graph starts at 1 and goes to -1, so its max is still 1, and its min is still -1. But this time, it starts at 1 and drops at 90 to 0 and then down to -1, turns back around to 270 at 0 and back up 360 is back to 1. The period of this graph is still 360 degrees. And then we've got the tan graph that we've seen before. So the way I think of drawing the tan graph is, if it's between 0 and 360, I'm starting at 0, it's going up steeply, but it never touches this 90 line, it's like a dotted line. And then it starts again from the bottom, steep, turning at 180 and going up steep. And then it starts again after 270, turning up, and it would just keep repeating that pattern. Key points, well, it's not got a max or a min, it just goes on forever, but it is 0 at these points here, so it's 0 at 0, and at 180, and at 360. These are called turning points, it's where it starts to turn, points of inflection. And it's got asymptotes at 90 and 270, asymptotes of where the graph never touches that line. Okay, so let's look at some examples of what you would do with this. So let's look at the amplitude first of all. Let's say I've got y equals 5 sine x. Well, the normal sine graph, which you need to be able to draw, goes like so, and that's just a wee quick sketch. And usually it goes to 1 and -1, the max and min is 1 and -1. But the number 5 means I'm timesing each value by 5, so the max is just becoming 5 and the minimum is just becoming -5, and it still goes 90 for the max, and then 180 at 0, 270 for the min, and 360 right at the end if these are degrees. So that would be the graph of y equals 5 sine x. You'd never have to draw it or identify it. For example, let's say y equals a half sine x. So the number in front, we'll just define this now, is called the amplitude of the graph. It's how high it gets up to. It's max and minimum value, and as long as there's no number on the end like this, then that would change. So the amplitude of this graph is 1/2. So we now know that the peak is a half high, or it spans a whole distance, a graph of 1. 2/2 is 1. So drawing my graph, depending on your scale, you could show that it is different, but keeping the scale relatively good, we now just know that the amplitude is a half, so it goes up to a half and down to -1/2. Notice the difference between here is 1, 2/2. And along the way, it's just going 90, still 180, 270, and 360 degrees. So that is y equals a half x. That's why y equals minus sine x. Well, we've still got sine x graph, but this time our maxes become mins and our mins become maxes, because if you imagine the max here with 1, I'm times it by -1, so it goes down to here. And imagine our min is -1, it's times it by -1, so it becomes +1. In other words, the graph goes upside down. So we would still have 1 and -1, but it's been flipped in the x-axis. And similarly, you can do the same if you put -3 or -4. Y equals -3 sine x, then I would go underneath and then up. But instead of being 1 and -1, it would be 3 and -3. Y and x. 90, 180, 270, and 360. So that is amplitude in a nutshell, and that applies to cos or sine. Okay, let's look at some vertical translations. That's when you add or take away a number. I'm just going to stick with the sine graph, but it works the same for the cosine graph. So let's say we had sine x plus 2. Well, we know that amplitude is still equal to 1, but our max and min have changed, because instead of going to 1 and down to -1, it goes to 1, then plus an extra 2. So that's 3, and it goes to 1, and it goes to -1, and then plus an extra 2, so it goes to 1. So it just goes between 1 and 3. So if we draw our graph, we've got our x and our y. It's still the standard sine graph, except I'm starting at 1 and I'm spanning up to 3. So I'm in the middle is 2. That's kind of now my new x-axis essentially, up to. And I'm just drawing the graph between the points. So that would be 90, 180, 270, and 360. With these ones, it's sometimes easier to use software to see this. So I'm going to show you a software for most of these. So the next one is sine x minus 1. So if I go to my graph here, so we've got our sine graph there. Notice that if that's 0, then this number here is -1. because it's starting at -1 instead of 0. And then the amplitude is just 1, so it's still just going up to 0, down to -2, and back up. Whereas, well, forget that point, back up to here. So let's just draw that on the side here. Y and x. So it's sine x minus 1. So our max is 1 minus 1, which is 0. And our min is -1 minus 1, which is -2. So we're going to -1 as our starting position, and then we're going down to -2 and up to 0. So it's just like so, where that kind of is our new axis. Okay, and then that's 90, 180, 270, and 360 degrees. Let's combine amplitude with a transformation. So the next one says graph is going to be 2 sine x plus 3. Well, let's see what it's going to look like first by typing in 2 sine x. And then we're going to say plus 3. So there's our graph there. Where do we get that from? Well, first of all, we look at our max and min. So the max is, remember, given by the amplitude plus 3. So in other words, 2 plus 3, which equals 5. And our min is given by the amplitude, but and our min's given in the same way, but our min, if the amplitude is 2, would be -2, so it's -2 plus 3. 3 minus 2 is 1. So it goes between 1 and 5. So there's 1, and there's 5, say. And in the middle of A numbers is 3. That's our y, that's our x. So that's kind of like where we're pivoting at. So just going up and down between the numbers. The amplitude should still be 2. 3 to 5 is 2. The amplitude is the height of the peak from the starting position. And we're still going 90, 180, 270, 360 because nothing's changed on the x-axis. If it asked us what's the max of this graph, the maximum point of this graph would be 5. If it asked us for the minimum value, it would be 1. Where does it happen? If it asked us where it happened, well, x-axis, 90. At 90 degrees, the max is 5. At 270 degrees, the min is 1. Of sine x minus 1, so the same idea with this one. All we're doing is changing the number in front to 0.5 because that's a half. And then it's -1. So we get a graph that kind of looks like that. So that's what I'm aiming for, but let's just try and get it ourselves. So we've got our max. Our max is the amplitude of a half minus 1. Well, a half minus 1 is minus a half. And our min is minus a half minus 1, which is minus 3 halves. So we now know we're under the y-axis. And we're starting at minus a half as our maximum value. We'll take a bit of space here. Minus 3 halves is our min. In between the 2 points, well, it's just spanning a half, remember? So that's -1. So that's kind of like our new position. And we're just up and down. So that's 90, again 180, 270, and 360. To switch this up, let's do a cos one. So 3 cos, and then it's x plus 2. There we go, we can see it there, but let's just get it ourselves. So our max, well, the amplitude is 3, so it's 3 plus 2 is 5. And our min, well, the amplitude is 3, so it's -3 plus 2, which is -1. Period is still 360 because it's just cos x. So remember, standard cos graph starts up and then drops. So we're starting at 5 as our max, and our min is -1 down there somewhere. And then the amplitude is 3, so 5 minus 3 is 2. So 2 is kind of our pivot point. So we're dropping, turning, going back up. 90 for here, 180, 270, and 360 finally at the end, and they're in degrees. So our max point is 5 and our min point is -1. Still happens in the standard places. The max happens at 0 and 360, and the min happens at 180 degrees. One last one, let's do a flip it upside down and then a take away. So in this one, we're going to do -2 cos x and then -1. So you can see what is done there, and that we will do it at the side. Our max is going to, but it's still going to go up to 2. Remember, -2 just flips upside down, so it's 2 - 1, which is 1. And our min is going to go to -2 - 1, which is -3. So there's our x and y axis. We're going up to 1 and down to -3. And the amplitude is still 2, so our point between the two numbers is -1. But remember, our graph usually goes down, up, and along. We're flipping that upside down, so it's going to go like that instead. So we can just draw that in. And these points, of course, where it crosses here is 90. That's 180. That's 270. And back to 360. And we're done there. Okay, let's look at multiple angles. I'm going to draw it first, and then you'll be able to see what's happening, yeah? So if I kind of zoom in a little bit, so we can only see up to 360, and I say I want the sine, and I just want 2x instead of 1x. Well, you should be able to see I've now got 2 waves instead of 1 wave. If I was to change that to a 3, notice what happens. If I just delete and say 3, I get 3 waves. 4 waves, and so on. So 2x is 2 waves. Now, how do we see that? Basically, the period of a graph is usually 360, but it's actually 360 divided by the number in front of x, which in this case is 2. So our period is 180. So remember, period means when does the graph start repeating itself? It starts repeating after 180. So if I have to draw it all the way up to 360, I have to draw the normal sine graph. Well, that's one of them, but I stop at 180. So I need to draw another one up to 360. So if it asked me to draw up to 360, I would draw 2 of them. And then we can just put points in. So that's 90, showing that 180 is when it's repeating itself, 270 and 360. The max and min still 1 and -1. Now, if we wanted some extra points, we could find the turning points because it's just in between. So it's just 45. It's just an extra 45 and an extra 45 and an extra 45 from the previous number. Let's look at another example, but this time a sine of a third x. Well, what does that mean? Well, the period, remember, is 360, but then divided by a third this time. Now, 360 divided by a third is the same as 360 times 3. Well, 3 nothings is nothing. 3 sixes is 18. 3 threes is 9 plus 1 is 10. So that's 1080 degrees. That means the graph doesn't start repeating itself until way back over there, which means if you only draw it between 0 and 360, you're only drawing a part of the graph. Let's have a look here, you'll see. 1/3 of x, I'll just type that in as 0.333 because it's easier. So you can see here, I'm only drawing a bit of it because it takes ages to get the whole graph in. Okay, so how would you draw that yourself? Well, you would have your graph. You know the max and the min is still 1 and -1. But you now know that 180 and 270, your normal turning point on your sine graph happens at 90, but it's going to happen 3 90s after that, which is 270. So as long as you work out where your turning point is, which is there, you can just kind of start drawing it and show that that's all you're going to get up to 360. Chances are you're never going to get asked to do something like that. Let's look at, skipping ahead, some cost graphs, so we're not doing this all day. So let's say we've got the cos of 2x. Then it's exactly the same idea. You can see that you get 2 cost graphs instead of 1. So I'm not going to draw it now. It's exactly the same. It goes to 1 and -1, and you just draw 2 instead of 1 up to 360. Same with cos of third x. The period for the cos of third x would be 180 because it's 360 divided Same with cos a third x. Okay, standard stuff, this one. If we go into looking at working out the equation from the graph, it says, write the equation of this graph in the form y equals a sine bx plus c. So we need to work out the amplitude. Now, how are we going to get our amplitude? Well, the easiest way to do that is find your max at 7 and find your min, that's 1. So it goes between 7 and 1. So I'll do 7 take away 1, which is 6. So that whole space it's taken up is 6. So the amplitude is 6, but then I just divide by 2. So 6 divided by 2 is equal to 3. Our amplitude is 3. That's our max. So that's the number in front. So we've got y equals 3 sine. Okay, next thing. How many graphs is there up to 360? When does it start repeating itself? So looking at the period, it goes 180. So I know my period is equal to 180. So that means b equals 2, because 2 times 180 equals 360. So I've got 2x. And then plus a number, well, my max is 7. And I've got an amplitude of 3. 3 plus 4 is 7, so plus 4, and I'm done there. This graph in the form y equals a cos bx plus c. So it's a cos one. So let's get our a first, our amplitude. Going up to here is a high point and there's a low point between -5 and -1. So there's 4 in between that distance. So our amplitude is half of that, so a is 2. How many graphs are up to 360? Well, just 1, so b is 1. And then I said a is 2. A normal cos graph looks like that. This is flipped upside down, so a is -2. And then to get our c, well, we just think about where does it normally start? If it was going to be -2, then it would start at -2, but it's actually starting at -5. So for c, I need to take away 3. So and finally we get -2 cos x, take away 3. Quick check at the end. -2 take away 3 is -5, which is the lowest point. So we're probably happy there. We can also look at some horizontal translations of phase angle. So we've got the graph of sine x minus 60. So let's look at the graph of sine x first of all. It's just standard graph. It goes 90, 180, 270, 360, between 1 and -1. If I add the extra graph, it's shifted to the right. And why is it shifted to the right? Well, the max usually happens at 90. The sine 90 is equal to 1. And that means the sine of x minus 60, well, that has to equal 90. So 90 minus 60 is not going to give me it. I can't take away 60 because 90 minus 60 is 30. The only way to get an answer of 90 is to do 150 minus 60. So it means I've shifted this normal point here, 90, has now become 150. And similarly, every other point is shifted on the graph. The red one is the new graph. So if it's x minus an angle, it's a shift to the right by 60 degrees. Okay, and then you just draw your new graph. What about adding then? Well, let's say sine of x plus 45. There's a standard sine graph. It's shifted to the left. Why is it shifted to the left? Again, because we want our max to be 90. So something plus 45 equals 90 is 45. I've moved back 45 degrees. So it's a shift to the left by 45 degrees. Cos graph, cos x plus 30, that's going to be a shift to the left by 30 degrees. Now, usually you're not going to draw past 0 or past 360. So when you draw this, let's just draw cos x. There it is there. When I draw cos x plus 30, you can see my new graph, I'll just get rid of the original graph, is there. So I'm not drawing everything. So how do I actually draw that? Well, what you imagine is, you imagine shifting back 30. So my new graph starts at minus 30. And then I'll just draw it as normal from there. But that means I'm up to 390. So now I'll just delete everything I don't need. So I would delete this bit. And I would delete this bit. So I'll kind of just draw it so that it goes between the points. Now, of course, we can combine these. So let's say we had the graph of 3 sine x plus 25 degrees. Then we know our max and our min is 3 and minus 3. And as a shift to the left by 25 degrees, because it's plus 25, it's going to rise up, fall down, and keep going. Obviously, this one we don't need, so we'll just kind of delete it away. And it'll not get to 360 because 25 degrees earlier, it'll go past there. So how do we work out these points? Well, all we do is take our normal points and take away 25. 90 minus 25 is 65 degrees. 180 minus 25 is 155. 270 minus 25 is 245. And 360 minus 25 is 325. We can draw that better on here. So it's 3 sine x plus 25. And you can see it there, pretty much the same graph. 2 sine 3x minus 4, so we're combining a bunch of stuff. So it's going to flip upside down, go to 2 and minus 2. There's going to be 3 of them. And then we're going to move the whole graph down by 4. So what does that look like? Well, we've got minus 2. And then we've got sine 3x, and then we've got minus 4. So you can see minus 2 sine 3x is drawn, 3 of them between 2 and minus 2. There it is there, 2 and minus 2. But then we take away 4, so we move down by 4. So the whole graph shifts down the way by 4. Last one we're going to look at, 5 sine 2x minus 30 plus 1. So we've got 5 sine, let's put just like 2x to start with, so you're getting a standard 2x, right? Unzoom that a wee bit. Okay, 2 of them up to 360. But then, inside here, I'm taking away 30. So we're shifting the graph to the right by 30. And then we're adding 1, so we're shifting it up. Now, often you'll not have to draw that from scratch. You'll have to just identify it from the graph. And you can see here, we're going to look at that now. So here's some past paper questions. SQA National 5 Maths, 2014, paper 1, question 10. Find the values of A and B. So amplitude first. Our amplitude, it spans. It goes from minus 3 to 3. So that's a span of 6. 6 divided by 2 is 3. So we know our amplitude is 3. So that means that A equals 3, because that's always our amplitude, the number in front. And then plus B means a shift to the left by a certain amount. So we can see here it's 40. It usually starts there. So that means that B must equal minus 40 degrees, minus 40, because I've shifted to the right by 40. And I'm done there. SQA National 5 Maths 2015, paper 1, question 6. The graph of A sine bx is shown. What's A and B? Well, we can see our amplitude is equal to 4 straight away, because it goes between 4 and minus 4. And then we count how many graphs are there up to 360. 1, 2, 3 up to 360. So that means that A equals 4 and B equals 3, and we're done there. SQA National 5 Maths 2015, paper 1, question 9. Put the following in order from smallest to biggest. Okay, that's a little bit trickier, but it's got cos values, so we can draw a standard cos graph. And that goes between 1 and minus 1, and that goes 90, 180, 270 here, and 360. And then it's just kind of, well, where is 90? 90's there, that's on there, that's 90. 100, which is right 100, would be about there. So that's a negative value. And then 300 would be about here. That's a positive value. So we could say that the cos of 90 is 0. The cos of 100, well, we don't know the exact answer, but it's negative. And the cos of 300 is positive. So we can now put them in order from smallest to biggest. It goes cos 100, cos 90, cos 300, and we're done there. SQA National 5 Maths 2018, paper 1, question 6. The graph of A cos bx is shown. What's A and B? Well, A is equal to 5 straight away, because The max and the min is 5 and minus 5, the amplitude. And how many graphs is there up to 360? Well, it looks like there's 2, but be very, very careful. It only goes up to 180. So it means there's actually 4, double that. So that means that B is equal to 4, and we're done there. SQA National 5 Maths 2019, paper 1, question 13. Part of the graph of y equals 3 cos x plus 45 degrees is shown. The graph has a minimum turning point at A. State the coordinates of A. Okay, so the best way to do stuff like this is to draw your standard graph to find out where that min is. That min usually is minus 1, and at 1, 90, 180, 270, and 360. So usually it's at 180 degrees, right? That's our key. But it's plus 45, so it's shifted to the left by 45 degrees. So 180 minus 45. So 180 minus 40 is 140, minus 5 is 135. So the coordinates are along 135 degrees, and then it usually goes down to minus 1. But this time, this graph is 3. So it goes up to 3 and down to minus 3. So it's going down to minus 3 here. 135 degrees, minus 3. Graph of A cos bx is shown. State the values of A and B. Okay, what's our amplitude? Our amplitude is 1 up to 5 is 4. So it's 4 divided by 2, which equals 2. So we know our amplitude is 2. So that means that A equals 2. But then B is easy because I've got 2 and my max is 5. So I must be adding 3. So it's 3. 2 plus 3 equals 5. Done. SQA National 5 Maths 2021, paper 1, question 16. The function is defined as f of x is 4 sine 3x. Evaluate f of 90. That just means replace the x with 90. So I've got f of 90 is equal to 4 sine 3 times 90. Well, what's that? That's 4 times the sine of 270 degrees. So what's the sine of 270? Well, you've got a graph. You know this. It goes, there's my graph here. So this time the amplitude is 4 and minus 4 because it's 4 sine. It goes 90, 180, 270, 360. At 270, we're at a min, which is minus 4. So that equals minus 4, and we're done there. SQA National 5 Maths 2022, paper 1, question 8. State the value of A and B for this graph. Well, the amplitude is 3. It goes 3 minus 3. A equals 3. And then it's sine bx. Well, we've only drawn one graph, but it only goes up to 45. So I'm working, how many does it do up to 360? So 360 divided by 45 is equal to 8. So B equals 8. And we're done there. SQA National 5 Maths 2023, paper 1, question 13. Part of the graph of cos x plus A degrees plus B is shown. State the value of A. Okay, state the value of A. So it's a cos graph that's shifted. So if I draw my normal cos graph, which is here, taking a point, let's take the minimum value. Our normal minimum value is happening at 180. But this one's shifted a bit. How much? Well, let's just count these. 1, 2, 3 divisions, that's 30 degrees. So I now know that that is 210 degrees. So it's shifted to the right by 30 degrees, which means that A is equal to minus 30. Why is it minus 30? Because a minus shifts to the right and a positive shifts to the left. What's the value of B? Well, B is moving up or down. Our max and min is usually 1 and minus 1. The max of this is 2 and 0. So 1 plus 1 is 2. So B is equal to 1. And we're done there. SQA National 5 Maths 2024, paper 1, question 8. The graph of y equals A cos bx is shown. Find the value of A and B. Okay, so for A, I check the amplitude. It goes to 7 and minus 7. So it literally is just 7. And then for B, I'm seeing how many waves there are up to 360. Well, that's 1, that's 2. So it's just 2. And we're done there. This has been a math video for the whole of Trig Graphs in National 5 Maths. Hope you liked that. If you did like the video, take care, stay safe, and goodbye.